Welcome to week 3, everybody. Hope that everything's going okay. I'm hoping that if it's not, you are reaching out to your teachers to make sure that we are helping you as much as we possibly can. Our job here is to try to make this as accessible as possible, and this was our idea. If you have needs that we were not aware of, or if you have a better idea, please reach out and let us know. I certainly did not sign up to be a teacher to be teaching you guys through a screen. So please let me know if there's any way that we can help you. And we will, of course, try to do that. So we are entering week 3. This week, we are going to learn one more law. So if you remember, just a quick refresher, we have gone through right triangles. We have gone through law of sines. And now today we are going to go through what's called law of cosines. So again, another formula that has been derived and proven by mathematicians. In pre-calc, you guys will derive the formula and you will prove the formula. I know that on Khan Academy, the proof is there for you if you are so interested in seeing that. But for our purposes, we are just going to try to solve pieces of a triangle using this law of cosines. So the law of cosines is a little trickier than the law of sines, but once again, there's a couple different versions. The law of cosines does not have a complete pair. So when we are looking for SOHCAHTOA, remember, you need a right triangle in order to use SOHCAHTOA. We can use law of sines when you're given that complete pair. But law of cosines is going to work when you're given different pieces of a triangle, namely, and not to bring you back to geometry too much, but if you're given side angle side or side side side, this is when you're going to use that law of cosines. So if this type of thing brings you back into some sort of fetal position, and you're feeling a little nervous about geometry and triangles, then this is really where I like to use that graphic organizer so that I can take it into a more algebraic context. I'm going to walk through the law of cosines with you. So the law of cosines states that if I have side squared, side little a squared, what this is going to be equivalent to is little b squared, so the other side squared, plus little c squared, minus twice b times c times cosine of the corresponding angle, cosine A. Now, Mr. Foster, who teaches geometry and also calculus and several other things, he likes to call this the train, where you've got the lead car and the caboose are matching and everybody else is along for the ride. So this would also hold true then if I started with b squared. Okay, so if I start with b squared, what will my formula say? Well, the other two sides. So I would be looking at a squared and c squared. So if you follow the pattern, I would then subtract 2ac, sides A and side C are along for the ride, times cosine of, remember the caboose has to match the engine, so cosine of that angle. And then of course the same thing would hold true for the last case. Wait a second. I found my mistake. B squared and a squared minus 2ba cosine of c. Okay, so here's your law of cosines. Again, I do feel kind of weird that I'm just kind of throwing this at you. We usually have some investigations and all that kind of stuff, but for this remote format, we're just going with it. Okay, so first, where I'm going to start out is I'm just going to go right into those triangles because you've been working with them for law of sines. So I'm just going to draw a non-right triangle to the best of my ability. Maybe something like this. And I'm going to call this angle A, angle B, angle C. And what I know is I know that angle A is 80 degrees. I know that little c is also 80. And little b is 64. Okay, so if I'm just looking at this, and let's say that my goal is to find the measure of BC. So let's say that I'm trying to find BC, and let's say that we're going to go to the nearest tenth on this one. Okay, if I'm trying to find BC, I know that BC is right here. And another way to talk about BC is to talk about little a, because that's the corresponding side. So I'm looking at this and I'm like, ooh, law of sines. So I'm saying this is my incomplete pair, which means I need a complete pair. There is no complete pair. Okay, so we have to come up with another option. Enter law of cosines. What is important about law of cosines is that if I am missing little a, I need to make sure, if this is my unknown, I need to make sure that I have my other two sides, which I do, and the included angle, which is big A, which I also have. So I could throw everything into a graphic organizer if I wanted to see it. So I know that big A is 80 degrees. I'm missing little a, but I have my other two sides. So I know that little b is 64 and little c is 80. I can tell right now I have no complete pair. So if you'd rather look this way, go ahead and throw that in there, and that's another way to go. So this time I'm going to focus in on my little a because this is the piece I'm missing. So I know I'm going to set it up. I don't know what squared equals b squared plus c squared minus 2 times b times c. Remember, Mr. Foster just says everybody's along for the ride. And now I also have cosine of 80 degrees. There's my A. Well, this is not so bad, my friends, because my unknown is already almost all by itself. What's the only thing we have to undo? Well, the only thing we have to undo is that squared. How do you undo squared? Square root. So as long as I square root, it's Desmos time. I can pop that whole thing right away, right into Desmos, which means I'm about there. So here's my Desmos. The first thing I'm going to remember to do is use my square root. My square root function is right down there. So square root, and I'm going to start typing this whole thing, and I'm going to go slowly. 64 squared plus 80 squared. You can see it's staying under the square root, minus 2 times 64. Whoops, I want to stay under the square root, times 80. Make sure you're still under there, all of your terms, and my parentheses. And now I've got cosine of my other 80. Sorry, I used two 80s there. That's could have been better planning. Okay, so I'm thinking that my side A is 93.4. Notice I rounded up because I'm going to the nearest tenth. So I think that side A is 93.4 degrees. So 93 point, I'm sorry, units. Okay, would a side of 93.4 make sense in this triangle? Absolutely. You've got side lengths of 80 and 64, and now also 93.4. So that makes sense to me. Okay, so that's one use of the law of cosines. Obviously, it's going to be a little bit more simple if you're missing a side. Now, your question, of course, should be what happens if you're missing an angle? Because we talked earlier, side, angle, side, or side, side, side. So what if we have a side, side, side? Okay, here we go. So side, side, side. Let's say we have something where we are looking at a triangle, maybe something like this, where we've got A, B, C, 9, 13, 15. Okay, and maybe we're missing angle B. So we could be asked to find the measure of angle B. And let's say that we're going to round to the nearest degree. Okay, so I've been given all sides. I have no complete pair, but as I look at my law of cosines, the angle that I've been given, or that I'm looking for, is angle B, which means this is the one that I should select in order to find angle B. All right, so I'm gonna lead the train with B squared. So if I'm going B, 13 is going to be little a, and 9 is going to be little c. Okay, so because I'm missing angle B, I'm going to use this equation right here. So I'm gonna start substituting. I've got little b squared is going to be 15 squared equals, now I've got the other two sides, 13 squared plus 9 squared, I'm just going through my equation, minus 2 times each of those. And then I've got the cosine of who knows what. We have no idea. Okay, so here's my unknown. This is why I saved this one for last, little ones. Wow, you could not be more buried than that particular unknown, which means I need to take all this stuff and move it to the other side, which traditionally can cause some trouble. So I have some hints. First of all, you might want to kind of chunk this out a little bit, if you will. This is not one of these where you can just throw the whole thing into Desmos and think you're okay. Maybe after a little bit of practice you could, but in the beginning, let's make sure that we're just evaluating as we go. Let me move my camera over a little bit. Okay, so the first thing I'm going to evaluate is 15 squared, which is going to give me 225. Now, I don't like to write down very much stuff if I don't have to, but in this particular case, it's really gonna help me. So I've got 13 squared now. I'm gonna do this piece next, plus 9 squared. And this is gonna give me 250. Now I'm gonna subtract all of this stuff. So I'm gonna subtract, notice I'm going into a different space every time. I'm not doing this all at once, or my order of operations is gonna get all messed up. 2 times 13 times 9 gives me 234. And now I still have times the cosine of b. And remember, this is the piece we need to isolate. So, biggest Algebra 2 mistake that is going to be coming down the way, that everyone who has come before you has done, but I am sure that 2020, this is the year where you will not try to subtract these two right away, no matter how tempting it is. Because remember, 234 is being multiplied by the cosine of b. It is not available for subtraction. So please resist the temptation to subtract those two terms. What you can start doing now is you can start undoing. We need to move things away from this angle. So I am first going to undo a positive 250. How do I undo a positive 250? Well, I subtract 250 from both sides. Okay, becomes 0. 225 minus 250, I end up with negative 25. And now who's remaining over here? Be careful, another famous Algebra 2 mistake. Don't forget to bring down that negative 234 times the cosine of b. Still looking for that b. All right, you guys are doing great. You're hanging with me. So now I need to undo this multiplication with division. You can see why I left this one for last. I'm going to be kind of lazy right now. I don't think I'm going to divide that yet because I only have one thing left to do. How can I undo cosine in order to get b alone? You got it. Inverse cosine. So I am going to take the inverse cosine of all that stuff. Oof. All right, calculator time. And then we should be there. So I've got funcs inverse cosine of negative 25. And obviously, if you can already see that you don't need to do negative 25 or negative 234 because you know those are going to divide out, you don't have to. I'm going to just for simplicity's sake. So I end up with an angle measurement of 83.866, which makes perfect sense in terms of an angle measurement, especially when I'm across from the largest side. So now I have to play the game here, the Khan Academy game, the SAT game, and I'm asked for the nearest degree. So I'm looking at 83, but that 0.8 is going to have push power, and that's going to be 84. Oh my goodness, look what you guys have just done. Are you serious? Mathematicians, all of you, I'm so proud of you. So good luck. As you can see, when you're missing the angle, it's tricky. You're going to be given 2 of each in that practice problem set. This is the longest video that you guys have had. I'm so proud of you. It's 17 minutes. I'm going to stop it now because you know that my favorite number is 17. All right, see you later.